Hi, I am Dr. Sai Prasad Reddy. Welcome to Software Testing, that interview questions and the frequent asked questions. Now, we are going to discuss about the topic cyclomatic complexity with an examples. So, what do you mean by the cyclomatic complexity and how we have to calculate this cyclomatic complexity and what are the advantages of calculation of this cyclomatic complexity? This we will discuss. See, cyclomatic complexity is nothing but it's one of the software metrics which is used to measure the complexity of the software product or complexity of the software program. That is, cyclomatic complexity is a metric which is used to calculate, which is used to know, or which is used to measure the complexity level of a particular program. So, this cyclomatic complexity has been introduced in the year of 1976. Since 1976, all the computer scientists are using particular equations to measure the complexity level of that particular program. Right? If the cyclomatic complexity value is more, that indicates the complexity of that particular program is more. I repeat, if the value of cyclomatic complexity is high, that indicates the complexity level of that particular software program is very complex. Right? Now, see, for every program, software program, we will design a flow chart. Right? Based on this flow chart, we can measure, we can calculate the cyclomatic complexity value. The cyclomatic complexity is given by the equation C is equal to number of decision boxes plus 1, or this can be also defined in some other way, the number of decision statements plus 1. So we can explain this any one of these equation, both are same, right? So the number of how many number of decision statements are there in that particular program plus 1, that this equation will give you the value of the cyclomatic complexity. Here C indicates cyclomatic complexity. Clear? And the next is, if at all, for that program, if the control flow is designed, it is nothing but a graph. Control flow for the particular software program, that is nothing but a graph. Based on this control flow, how can we calculate, how can we measure, how can we find the value of cyclomatic complexity? If at all, if we are using control flow graph for a particular software program, then we will calculate, we will measure, we will find the cyclomatic complexity by using the equation C is equal to E minus N plus 2 into P. Here, what do you mean by the C? C is nothing but the cyclomatic complexity, and E is nothing but the number of edges in a flow graph. That is, in a control flow graph, and n is nothing but the number of nodes in that particular control flow graph, and this p is nothing but the number of nodes that have exit points. That is this is a formula which is used to find the value of cyclomatic complexity based on control flow graph for a particular program. Clear? Now see, this we will discuss, and this we can understand by using some examples. Now see. Now for the given following code, what is the value of the cyclomatic complexity? See, this is the program. Read A. If A is greater than 0, then if A is equal to 21, then print a hello, end if, end if. This is the code, following code. For this code, what I have done is, I have designed the flow graph, that is a flow chart, sorry. I have designed this flow chart for this program. By looking into this flow chart, we can calculate the cyclomatic complexity value here. So how many number of decision statements are there here in this program, or in this, if you take this first program, how many decision statements are there? 2 statements are there. If is one condition table or decision statement, and the second if is second decision statement. How many decision statements are there here? 2 decision statements. So according to the definition, 2 plus 1 decision statements, number of decision statements plus 1, that is equal to 3. If you look into this flow chart, how many decision statements? Decision statements, you know very well. All these decision statements will be defined, will be noted in the form of decision boxes. This is a decision box. This is a decision box. How many decision boxes are there? 2 decision boxes. According to this formula, number of decision boxes in that particular total program, in that particular total flow chart, plus 1. That is 2 plus 1 is equal to 3. So the cyclomatic complexity value of this particular program is 3. Now, for the same program, here I have not denoted, here I have not designed. Just I am explaining orally. For the same program, if we design control flow graph, then how to calculate the cyclomatic complexity? See, here this is a one. Based on this concept, now we have to calculate the cyclomatic complexity. Very simple. See here, what do you mean with the E here? Number of edges in the program. That is nothing but the number of lines which are connecting to the nodes in the program. Node. And what do you mean with the N? The number of nodes, the total number of nodes in a particular flow graph. See, and what is this P? The number of nodes that have an exit points. That is called P. Here, if you design control flow graph for this particular program, now for that control flow graph, you will have the number of you will have the number of edges as a 6, and the number of nodes are 5 plus 2 into the number of exit points 1. So that is 6 minus 5 plus 2 into 1, that is 3. So even if you calculate based on the flow chart, you will get the value 3. Even if you calculate even if you calculate the cyclomatic complexity based on the control flow graph also, it will get the same value. Because for any program, the cyclomatic complexity is a fixed one, it will not change, irrespective of the method of measuring the complexity level. Right? See, but Now I am explaining this second thing, control flow graph, just simply by using this flowchart. But of course, this is only for your understanding. But if you want to note, please keep in mind, if you want to calculate complexity, cyclomatic complexity based on the control flow graph, you have to design the control flow graph. Here I have not mentioned, here I have not designed control flow graph. Just I have mentioned, I have designed only the flow chart. Anyway, so here these boxes are called nodes. Node. So totally how many number of nodes are there? 5 nodes are there. N indicates nodes 5. And see how many lines are there, connecting lines for each and every low node. 1, 2, 3, 4, 5, 6. Right? Totally how many what you call edges are there? 6. Edges are nothing but connecting lines between the nodes. Total number of connecting lines. So this is a one, this is second one, this is third one, fourth, fifth, sixth. There are 6 connecting lines. That is, connecting lines are nothing but edges. So total number of edges are 6. Total number of node 1, 2, 3, 4, 5. Total number of nodes are 5. 5 plus 2 into 1. What is the exit number of exit points? Only 1 is the exit point, end. Into 1. That is 3. So like this you have to calculate. But obviously I am repeating, just by using the flowchart only, just I have giving explanation. But if you want to calculate complexity, cyclomatic complexity value based on this control flow graph, you have to design the control flow graph. Here I have not designed, just I have explained for your understanding only, right? So for the given following code, the cyclomatic complexity value is 3. Take some next example. This is the program. For this program, we have to calculate, we have to find the cyclomatic complexity. Now see, for this program, I have designed flowchart. This is a flowchart for this particular program. And according to this equation, the number of decision statements plus 1. How many number of decision statements are there here? Very simple. Looking into the program also, you can easily understand. If is one decision statement, here if is a second decision statement. Yes or no? So these conditions, decision statements are nothing but conditions. Here in the flowchart also you can see this is one decision box. This is the second decision box. That's all. Only 2 decision boxes are there. So now the cyclomatic complexity is nothing but number of decision statements plus 1. 1 is a fixed one, constant, right? That is equal to 3. Now, if you calculate, if you design control flow graph for this particular program, and if you calculate the cyclomatic complexity value based on this control flow graph for this particular program, you will get 9 edges and 8 nodes plus 1 exit, that is equal to 3. 9 minus 8 plus 2 into 1, that is equal to 3. So even if you calculate the cyclomatic complexity based on the flowchart, or even if you calculate the cyclomatic complexity based on the control flow graph, both are the same. You can use any one of these methods to find cyclomatic complexity. So this is very important interview question. So generally, predominantly, this question will be asked in the interviews for the software developers positions, and even in so many technical screening tests also, they will give you the questions on this particular topic. And in the interview also, they will ask you about the cyclomatic complexity. So you have to explain this cyclomatic complexity like this. right? It is very, very, very important. And even for ISTQB also, sometimes they will ask, this is a simple one, but even sometimes they will ask to find the value of cyclomatic complexity by giving a program. Clear? This is all about the cyclomatic complexity. So please subscribe my channel, share my videos to all the students who are searching for the job in the IT industry. And like my videos, and please don't forget or don't hesitate to raise your comments in the comment box. Thank you very much.